This is a maths example of differentiation using the product rule. In this example, we'll be using f of x equals x to the power 6. We know from algebra and rearrangements that x to the a times x to the b equals x to the power of a plus b. In this equation, we have x to the power 6. This means we can separate x to the power 6 into two values of x where the powers add up to 6. We could use 3 and 3 or 5 and 1, but in this example we will be using 4 and 2. Clearly, when differentiating this equation, we cannot use the general rule that we've been using in the past. We must use the product rule. To use the product rule, we simply use this general rule, where f of x equals u times v, dy by dx, or in this case f dash x, is equal to u times dv by dx plus v times du by dx, where u is u and v is v, and dv by dx is v differentiated with respect to x, and du by dx is u differentiated with respect to x. In this example, u is going to equal x to the 4, and v is going to equal x squared. It doesn't matter which way round the u and the v go. Now let's put some values into our general form. U is x to the 4, and dv by dx is v differentiated with respect to x. V is x squared, so this will become 2x to the power 1. V is x squared, and du by dx is u differentiated with respect to x. U is x to the 4, which when differentiated will become 4x to the 3. Now let's simplify this equation. X to the 4 times 2x to the power 1 becomes 2x to the power 5, and x squared times 4x to the power 3 becomes 4x to the power 5. Simple addition gives us 6x to the 5. Clearly you can see if we took our original equation and used the general rule that we are familiar with from the past, we can see that there is no a value, that x is x, and n is 6. N is 6, there is no a value, x is x, and n minus 1 is 6 minus 1, which is 5. You see that this example, this value matches with this value. Clearly, for equations of this nature, simple differentiation is preferred. For more complex examples, where you have one value multiplied by another value of x, the product rule is required.